Okay, lesson 2 is solving second degree trig equations. So what that means is that instead of just sine of x, you've got sine squared of x, second degree. And I just want to remind you that sine squared of x is the exact same thing as sine x squared. Okay? So it's just, you'll see it written as sine squared x, but it means sine x squared. Okay, so right away, when you see that, it's in the form of a quadratic equation. So when that happens, there's factoring that needs to happen. In this case, we're going to learn how to factor trig expressions. So just as you would with any regular polynomial expression, and you factor trig expressions the exact same way, okay? So you're going to use that in this lesson to solve trig equations, and then you're actually going to use it again in lesson 6 when you're proving trig identities as well. So this is a really important skill in this unit. Okay, okay, and in factoring trig expressions, you just apply the 3 basic factoring techniques where you factor out a common factor. You may see some differences of squares, and you may see trinomials like this that you have to factor. Okay, so let's just, for a quick review, just see how we would do that in each of these cases where we have trig equations as a part of the factoring process. So in this one, we've got 8 tan a plus 4. Well, I see a common factor there of 4 that I can factor out. So that would just be 4 times 2 tan a plus 1, right? Because you would multiply the 4 by the 2 tan a to get 8 tan a, and you would multiply the 4 by the 1 to get 4, okay? So it's just regular factoring it out, okay? You're just seeing this whole part here together as one thing, okay? So in the second one, sine squared x, so that means sine x squared minus 3 sine x. Well, I see that I can factor out, I've got an extra sine x in each of those, so I'm going to factor out the common factor, the sine x. So that would leave me with sine x, because sine x times sine x would be sine squared x, or sine x squared, same thing. Oops, I wouldn't put my ending brackets there yet, minus 3. Okay, you can see how, if you multiply that out, sine x times sine x gives you sine squared x, and sine x times 3 gives you negative 3, gives you negative 3 sine x. Okay, this one here, this is Mrs. Baker's favorite kind. This is a difference of squares. So remember, when you factor a difference of squares, you find the square root of each of those perfect squares, and you put them in the brackets, and one set of brackets you put the adding sign, and the other bracket you put the subtracting sign. So what is the square root of 4 sine x squared? 2 sine x. So you're going to put one of those in this bracket and one of those in this bracket. And then what's the square root of 1? Well, obviously it's 1. One of them is going to be added, one of them is going to be subtracted. All right, now these bottom ones, we've got degree 2. So this is cosecant squared x minus 3 cosecant x minus 28. Okay, so just like before when we had an equation that looks very similar, x squared minus 3x minus 28. Okay, you'd be looking for two numbers that would multiply to give you negative 28 and add together to give you negative 3. It's the exact same thing here. Don't let that fact that there's a cosecant in there distract you. It's the exact same thing, okay? So we're looking for two numbers that will multiply to give us negative 28, and they will add together to give us negative 3. Okay, well, negative 7 and positive 4. Negative 7 plus positive 4 is going to give you negative 3. Okay, so this factors to cosecant x minus 7 times cosecant x plus 4. Okay. All right, and the last one. This one is a little bit different because like in this case, this was the same thing as having just an x squared variable because the coefficient of the x squared was just 1. In this case, when we have a coefficient that is a number other than 1, remember we have to use the method of decomposition to factor this. Okay, so just a really quick review. Maybe let's just go up to the very top of the page and do a quick review just so that you are reminded how we use the method of decomposition. Okay, if we'll just do it with a regular ordinary equation, and then we'll use what we did there. Once we kind of remember the steps, we'll be able to apply it to the cosine function. Okay, so if I give you this equation, 2x squared plus 4x minus 6 equals 0, of course, because it would equal 0 if it was an equation. Okay, now because I don't have just x squared, I've got some coefficient in front of x squared. Remember, that's where you take the 2 times negative 6 to figure out two numbers that will multiply to give you negative 12, and those same two numbers that will add to give you positive 4. Okay, well, those numbers would be 6 and negative 2, 6 and negative 2. Okay, so remember you're going to split this middle term into 6x and negative 2x. So you're not changing the value of that middle term. Okay, but you kind of have to figure out which one are you going to put first. You want to group it so that it can be factored with this 2x squared or with this negative 6 at the end. So I think it would make sense to put the negative 2x first, and then the positive 6x, and then you have your negative 6 at the end still, right? Okay. Now do you see that this middle term, remember, is still negative 2x plus 6x? That's still positive 4x. So we haven't changed anything. We've just decomposed or split up that middle term. Okay? So now again, remember, you group your first two and you group your last two. Leave your sign in the middle where it is. And now we can do some factoring of common factors. So I'm going to factor out a 2x. So if I do that, I'm left with 1x and minus 1. And then if I do that here, I'm going to factor out a 6, and I'm left with x minus 1. And remember, you want these two factors to always be the same. Okay? You'll know you've done it right if they are. Then you group everything outside of the brackets together. So you've got 2x plus 6 as one of your factors, and x minus 1 as your other factor. Those are both equal to 0. So then you would solve by saying, well, 2x plus 6 is 0, and x minus 1 is 0. And so just using regular algebra, you would subtract 6 from both sides, and then you would divide by 2. And then you would put it in lowest terms, so negative 6 over 2 is negative 3. So x is either negative 3, or in this case, x is 1, adding 1 to both sides. Okay, so is that ringing some bells? Are you remembering how to do method of decomposition? Because now we're going to do that exact same factoring method, but there's a cosine as a part of our x terms, okay? But it is the exact same thing, nothing different, okay? So what I'm looking for are two numbers that will multiply to give me negative 8, and they will add together to give me positive 7, okay? The two numbers would be negative 1 and 7. Negative 1, oops, sorry, 8. Negative 1 times 8 is negative 8. Negative 1 plus 8 is positive 7. Okay? So now I'm going to just rewrite my exact same equation. Maybe I'll switch to a different color just so that we can tell where D ends and E begins. So I'm going to write 2 cos squared x minus 1 cos x plus, I'm just going to get rid of this. We remember our other one is 8, just so that I have the room, plus 8 cos x minus 4. Okay, then again, I'm just going to factor out any common factor. And in this case, I do have a common factor of cos x. And that will leave me with 2 cos x minus 1 in brackets. And in this case, oh, remember I'm grouping those two and these two. So now out of the second pair, I'm going to factor out a negative 4. And that will give me 2 cos x plus 1. Oops, I'm sorry, minus 1. Because I want to factor out a positive 4. I'm sorry, factor out a positive 4. Okay, because I need these two to match, and they won't match otherwise. So factor out a positive 4. That would be 2 cos x, and then I will have minus 1. Okay, now these two factors are matching, so I know that I'm okay. So I'm going to group the two that are outside of brackets, so that's cos x plus 4 is one of my factors, and the other factor is 2 cos x minus 1. Okay, and that's my final answer. I can take it further and solve it if this were equal to 0, but in this case it's not, and so I'm just going to leave it at that. Okay. Now we will come back and do this question number 1, which gives you some practice factoring those, but we'll do that at the end of this lesson. We're going to actually jump over to the next page, class example number 3 at the top of the next page. Because I want to show you now that we've done some algebra with factoring, we're going to learn how to solve second-degree equations where they do equal 0 using an algebraic approach. Okay? Okay, so when it says to us, use an algebraic approach to determine the roots of the equation, what does that mean? Roots are what? Those are your x-intercepts, if this was if you were graphing this, right? And so what that really means is solve for x. Okay? And again, it tells us our domain, where x is going to be between 0 and 2 pi. And it asks us to give solutions as exact values. Okay? So in this case, we're going to leave it in pi's, in radian mode, just because then we will have exact values and we won't be rounding decimal numbers to and getting inexact values. Okay? So again, here I have my equation. But if I want to solve it and find the roots, if I want to solve for x, I need to get everything over on one side so I can make this equation equal to 0. So I'm going to have 2 sine squared x. And then I'm going to add sine x to both sides. And subtract 1 from both sides. And then I will have equals to 0. All right, now once again, I have to factor this. So I'm looking for two numbers that will multiply to give me, now this again is a situation where I don't have just a 1 in front, I've got a 2 in front. So 2 times negative 1, it's going to equal, they'll multiply together to give me negative 2. They will add together to give me positive 1. Okay, the numbers that I'm looking for are negative 1 times 2 would give me negative 2, and negative 1 plus 2 would give me positive 1. Okay, so again, I'm going to rewrite my equation, 2 sine squared x, and this middle term here, I'm going to decompose now into negative 1 times sine x plus 2 times sine x, and then I still have this negative 1 at the end, minus 1 equals 0. Okay, now again, group the first two, leave your sign in the middle, group the last two, and I'm going to factor out what I have in common. The common factor here is sine x, and so I would have 2 sine x minus 1 left, and in this case, really I just have plus, that's assumed that it's 1 times 2 sine x minus 1, and that equals 0. Okay, so putting this plus 1 in there doesn't do anything, because if you just times by 1, you're not changing the value of it, but it's going to just make it easier for me when I group these two terms together, the terms that are outside of the brackets. It's easier if I see that 1 there. So I've got sine x plus 1 as one of my factors. The other factor is 2 sine x minus 1, right? These are the same, okay? And they need to be, so that I know that I've done it right, okay? Now, because this is an equation and I have to solve for x, I want to find my roots, I'm going to set sine x plus 1 equal to 0 and 2 sine x minus 1 equal to 0. Okay, I'm just going to have to finish that over here, so we'll bring this back up over here. I hope you have some space on your paper left. So sine x plus 1 equals 0, and on the other side, oh boy, I don't have much room, 2 sine x minus 1 equals 0. And I'm going to just divide it in half here so that we can see this is two different solutions. So just using regular algebra, sine x equals -1, or the other solution would be 2 sine x equals 1, and then divide by 2, sine x equals 1/2. Okay, now at this point, once I have my two solutions, I can just look on my unit circle and see where sine x equals 1. Where does sine equal 1? Or sorry, -1. So look on your unit circle, where does sine equal -1? Sine is -1 at 3 pi over 2. And where is sine equal to 1/2? There are two places where sine is equal to 1/2, at pi over 6 and 5 pi over 6. Okay, so this solution actually has 3 roots, 3 answers, okay? So if you use the unit circle, it is really easy because you can just read your solutions right off of the unit circle. Now, of course, if you didn't use the unit circle, once you have this, you can put that in your list, and you'd have to go through a whole bunch more steps. It really is just much easier just to use your unit circle, and you can actually just read where sine is -1 and where sine is +1/2. So again, I'm going to say, make sure that you've learned your unit circle, make sure that you know it, and that you're writing it out every day so that you have it at your fingertips and you can save yourself a ton of steps. Okay? Okay, so B just wants us to state the general solution. So remember from the last lesson, this means for all of the values of x that would possibly answer this question. So in this case, this is a sine function, right? So when it is sine, we know that its period is 2 pi. So that means we're just going to take each of these solutions that we got, 3 pi over 2 and pi over 6 and 5 pi over 6, and we're just going to add multiples of 2 pi to it. So pi over 6 plus some number of multiples of 2 pi, and then 5 pi over 6 and some number of multiples of 2 pi, and 3 pi over 2 plus some number of multiples of pi. Okay, and then remember we need to say that n is an integer, so it could be positive ends or negative ends. So we're adding or subtracting some multiple of 2 pi each time. Okay, full circle around. All right, and then again, sometimes they will restrict that domain like they've done in these cases, and it's the exact same thing. We just factor it. Well, look here. When you look at these, 4 sine squared a, negative 1, this is a difference of squares. These are the easy ones to factor. Maybe that's why they're my favorite. Okay, so what is the square root of 4 sine squared a? 2 sine a. And you're going to put one of those in each bracket. What is the square root of 1? One of them you're adding, one of them you're subtracting. Okay, then of course that is equal to 0. Okay, so we're going to set each factor equal to 0. 2 sine a plus 1 has to equal 0, and 2 sine a minus 1 has to equal 0. And so that would mean 2 sine a, I'm going to subtract 1 from both sides, then I'm going to divide by 2. So sine a is negative a half, or on this side, 2 sine a equals add 1 to both sides and then divide by 2. Sine a is either negative 1/2 or positive 1/2. Okay, so again, use your unit circle. You can see right off your unit circle where sine is negative 1/2. If you look on your unit circle, I'll give you a minute to look. Sine is negative 1/2 at 7 pi over 6 and 11 pi over 6. And sine is positive 1/2 at pi over 6 and at 5 pi over 6. So all 4 of those would be your answer. And then, in this case, it wants us again to give the general solution. So in other words, for all values. So again, you would just add the period. And again, this is a sine function, so its period is 2 pi. So you're going to go 7 pi over 6 plus some multiple of 2 pi, 11 pi over 6 plus some multiple of 2 pi, pi over 6 plus some multiple of 2 pi, and 5 pi over 6 plus some multiple of 2 pi, where our ends are again integers, positive or negative numbers. So this would be your final solution, the general solution for all values of n of x. All right. Last one on this page. So I'm just going to erase this. I just need the space. This is a tan equation, so right away I'm going to remember that the period is only pi. Remember, the period of tan is just pi. It's not 2 pi like cosine and sine. Okay? So again, to factor this, oh, this is easy to factor. I'm just going to factor out 1 tan x. So that leaves me with a tan x plus 1, and that equals 0. And so that means, remember, this is one factor that equals 0, but this is also one factor that equals 0. So tan x equals 0, and tan x plus 1 equals 0. So tan x equals 0 is done for us. This one, I just have to subtract 1 from both sides. So tan x equals -1 or tan x equals 0. Okay, well I can look on my unit circle. Where does tan x equal 0? Well, it equals 0 at 0, pi, and 2 pi. Okay, where does tan x equal -1? Well, it equals -1 at 3 pi over 4 and at 7 pi over 4. So there are my 5 solutions, just looking on my unit circle. So again, for the general solution of this, I'm going to just add pi to each of these terms. So if I take the 0 and I add pi, I just have pi. So some number of pi's, okay? If I add some number of pi to pi, so pi plus some number of pi, and then I take the 3 pi over 4, and I'm adding some number of pi, and I take the 7 pi over 4, and I'm adding some number of pi. Okay, flip over to the next page, and this time we have a domain that is specified, and so we have to answer to the nearest degree. This question is in degrees, and if I'm going to factor this, I'm looking for two numbers that will multiply to give me -28, and those same two numbers will add to give me -3. So I'm looking for -7 and +4. Okay, so that would factor to cosecant x -7 and cosecant x +4. And that equals 0. Okay, so cosecant x, oops, add set, oops, set it equal to 0. I'm skipping a step here, I guess. And cosecant x +4 also equals 0. Okay, then I can add 7 to both sides. And so you've got cosecant x equal to either 7 or -4. Okay, now at this point, I can't plug that into my calculator to see how many degrees that is, so I'm going to need to use the inverse. So the inverse of cosecant is sine, right? So I just need the sine of 1/7, right? Because it's the inverse, I have to remember to flip it. So this is the same thing as saying the sine of -1/4. Okay? Well, when you plug this into your calculator, or look, you can't really look on your unit circle because we don't have any values where sine x will be 1/7. So you'll have to plug it into your calculator to figure it out. So you'll do sine of 1/7, and that gives you an angle that is 8 degrees. Okay, that's your reference angle. If you plug into your calculator here the inverse of -1/4, you're going to get an error message. And the reason for that is because sine and cosine and tangent, remember you always use the absolute value. This value here would have to be positive, and so you can't take the sign of a negative number. So this actually means there is no solution in this domain or on this domain when you get that error message. Okay, it's not possible is what that means. Okay, so think about this though. If I have all suckers take chemistry, where is sine positive? Well, sine will be positive in this quadrant and sine will be positive in this quadrant. Okay, I have my reference angle. I know that it's 8 degrees. oops, that's supposed to be a little 0, 8 degrees. Okay, so one of my angles then is 8 degrees. And the other one I have to calculate by going 180 minus 8 degrees, which is 8 degrees and 172 degrees. Okay. And this is within my restricted domain. Okay. If I added another period, another 360 degrees, I would be outside of the domain. Or if I subtracted 360 degrees, I'd be outside of the domain. So this is the only answer, 8 degrees and 172 degrees. Okay. The last one. The last one I've got 2 cos squared theta plus 5 cos theta minus 3. So again, I'm just going to factor that. I'm looking for two numbers that when I multiply them, they're going to give me negative 6. I have to use method of decomposition because I have a 2 as a coefficient in front of my x squared, don't I? Okay, and then I need two numbers that when they're added together, they're going to give me positive 5. Okay, so I'm actually looking for negative 1 times positive 6 is going to give me negative 6. Negative 1 plus 6 is going to give me positive 5. Okay, so I write my equation 2 cos squared theta. It's this middle term I'm decomposing, and I'm going to decompose it into negative 1 cos theta plus 6 cos theta minus 3. Okay, then remember you group those two, leave your sign in the middle, and what do I have in common that I could factor out here? I can factor out a cos theta, and when I do that I have 2 cos theta minus 1, and then I have plus, and again I'm going to put in a 1 there because 1 times this. Oh, no, I guess I don't need to actually, because I can factor out a common factor here. I have a common factor of 3 I can factor out. So that would leave me with 2 cos theta minus 1. Okay, once these are the same, I know I'm good. So I'm going to put cos theta plus 3 together. Those are the two terms that are outside of the brackets. Group them together. And then your other factor is 2 cos theta minus 1. And that all equals 0. Okay, so I've got cos theta plus 3 equals to 0, or 2 cos theta minus 1 equal to 0. Okay, so again, cos theta equals negative 3. Subtract 3 from both sides, or 2 cos theta equals 1, divide by 2, cos theta equals 1/2. Okay, so look on your unit circle first of all. Where is cos theta equal to 1/2? Where is cos equal to 1/2? It's equal to 1/2 at pi over 3. Anywhere else? Oh, yeah, at 5 pi over 3. Cos theta equal to 1/2. Okay, those two spots. And what about cos theta equal to negative 3? Think about that for a minute. Is it possible to even have cos ever equal to 3 or negative 3? No. Cos and sine are only ever going to be between 1 and negative 1. That's the maximum and the minimum points of their graph, right? And so if you get a value that is beyond that, that means there's no solution. Cos theta will never be greater than 1 or less than -1. Okay, now let's just think about this for a minute. Okay, I have two solutions here, but I also have a restricted domain. Okay, so we need to figure out which of these, or would both of these be acceptable solutions. So here's, all suckers take chemistry. Okay, where would cos be positive? Well, it would be positive here, and it would be positive here. Okay, what I figured out is that this angle is my pi over 3. If you look on your unit circle, this one is 5 pi over 3. Okay, so I found those two spots. Okay, so the question is, are both of those acceptable answers if my domain is from -pi to +pi? Okay, so what that means is, if I'm going +pi, I'm going this way. If I'm going -pi, I'm going the other way to pi. Okay, so what that means is, when I'm going this way, how much is this little angle here? Pi over 3, right? When I'm going this way, it's this little angle here, isn't it, that they're asking for? And what's this little angle? Negative direction, pi over 3, right? If I go all the way around, like to there, I got 5 pi over 3. But this is saying I'm going a negative domain this way, okay? So I'm going negative pi over 3. That's 1 pi over 3 section, okay? So my answers are actually pi over 3 and negative pi over 3 on that restricted domain. Okay? It's actually just asking for these little angles. All right, so the questions we're going to do to go with this assignment are, number 1, just do alternating questions. And then please do number 2 to 4, 7, 8, and 11 to 13 as well. Okay, again, pause or stop this video, do those questions so that you're comfortable with those ones before you move on and watch the third video, okay?